Hello everyone. Welcome to my presentation on client-server systems and web-based databases. Throughout this presentation, we'll discuss advantages and disadvantages of client-server system security, disadvantages of client-server system single point of failure, system backup and survivability situations, client-server system scalability, back-end processor and front-end processor, experience with Google Docs and Microsoft Teams as it relates to client-server systems, client-side scripting languages like JavaScript and jQuery, and client-server system programming development frameworks like Python. Client-server systems are networked architectures which link clients, i.e. computers, to servers. This supports a common method for distributed computer power within companies, linking clients to a central server to execute resources such as file and database requests. This provides a user-friendly interface, enabling multiple users to access the same pool of resources simultaneously. Client-server systems use a central server to provide strong authentication and access control. However, misconfigured permissions can lead to data breach, integrity loss, and confidentiality issues. These systems are also vulnerable to attacks like man-in-the-middle and denial of service. Maintaining security relies heavily on competent IT staff to configure and protect the system. In a client-server architecture, the server acts as a single point of failure. If it fails, all clients lose access. Network disruptions, such as routers or network switches going down, can also halt operations. For example, a server failure during payroll processing could prevent employees from being paid on time. Redundancy measures, such as backup servers and workload distribution, help mitigate these risks. Backup systems ensure survivability for mission-critical functions in areas like finance, operations, and healthcare. Redundancy can include backup servers, database replication, and trained support staff. This prevents business disruption, productivity loss, and financial hardship while maintaining reliability and the benefits of a client-server system. Scalability allows a client-server system to perform efficiently under increased demand. Horizontal scaling adds more server nodes, while vertical scaling upgrades server hardware like CPU, memory, or storage. Careful design, load balancing, and attention to bottlenecks like network latency or data consistency are crucial. This ensures systems can handle large numbers of users or high data volumes. The back-end processor handles server-side operations, including data storage, business logic, and database communication. It supports multiple clients without overloading devices. For example, an e-commerce system calculates totals, updates inventories, and processes payments, while social media platforms manage authentication, posts, and user profiles. The back end ensures smooth, reliable system functionality. The front-end processor operates on the client side, handling user interface rendering, capturing input, and displaying output. It complements the back end by offloading user-facing tasks. For example, a retail point-of-sale system shows product information, records barcode scans, and sends transactions to the server. This provides seamless user interaction while the back end manages heavy computation. I have personally used client-server systems through Google Docs and Microsoft Teams. In college, Google Docs allowed me to collaborate on documents with peers in real time, while Microsoft Teams helps me organize files, create collaborative channels, communicate via chat or video, and share documents efficiently in my current profession. These experiences demonstrate how client-server systems provide user-friendly interfaces, simplify permission management, and ensure data integrity, availability, and reliable access. Client-side scripting languages such as JavaScript and jQuery enhance interactivity and manage client operations. They allow dynamic content, form validation, document object model manipulation, and event handling without frequent server requests. This reduces delays, frees the back end for critical tasks such as authentication and transactions, and improves overall responsiveness. Server-side frameworks such as Ruby on Rails, Django, Flask, and PHP simplify web application development. They manage client requests, data handling, and security efficiently. These frameworks provide pre-built libraries, model view controller design patterns, and automation for repetitive tasks, supporting scalability, reliable, multi-client operations without creating bottlenecks. Client-server systems centralize management, improve security, and allow for scalable performance. Of course, risks such as single points of failure, misconfigured permissions, and cyber attacks still exist if the system is not carefully managed. By implementing disaster recovery, redundancy, and balancing front-end and back-end processing, organizations can ensure reliability and smooth performance. Overall, the client-server model offers a secure, efficient, and scalable framework that is essential for running modern businesses, supporting collaboration, and managing large volumes of data effectively. Thank you for watching, and I hope this gives you a better understanding of how client-server systems work and why they are crucial in today's digital world.